Welcome to the session on logic. In this session, we discuss problem of induction. Inference is a mental process in which from certain given statements we derive conclusion. There are two types of inferences, inductive and deductive. In deductive inference, two statements are given to us and one of them must be a universal statement, and we have to derive from it a conclusion that is less general than the given premises. Inductive reasoning proceeds from less general to more general propositions. In deductive reasoning, we give importance to formal validity alone, whereas in induction both formal and material validity are considered important. If the conclusion of an argument necessarily follows from its premises, then it is said to be formally valid. If the ideas in an argument correspond to the fact of reality, then it is said to be materially true. Deductive logic is believed to be concerned with the conditions under which particular or instantial propositions are inferable from universal premises. Inductive, on the other hand, is conceived as dealing with those inferences which enable us to derive universal conclusions from particular or instantial premises. What is induction? Aristotle employed the term induction to denote the mental process through which a universal character or relation is discriminated and identified in an actual case or event. Induction is a process of arriving at new knowledge from certain given facts. The given statements are known as premises. Inference is a mental process in which a thinker passes from one or more propositions to some other propositions connected with the former in certain way. The most important factor in inferential knowledge is the relation between the given propositions and the inferred propositions. According to J. S. Mill, induction is the process by which we conclude that what is true of certain individuals of a class is true of the whole class, or what is true at certain times will be true in similar circumstances at all times. For example, our observations regarding the mortality of individual human beings, we come to the conclusion all human beings are mortal. A is a human being and he is mortal, B is a human being and he is mortal, C is a human being and he is mortal. Therefore, all human beings are mortal. Thus, induction is the mode of generalization in which we express that what is true to some members of a group is true to the whole group. In induction, the conclusion is more general than the premises. The first step in induction is the proper observation of particular facts. Induction are of two types, strong and weak. The words strong and weak are sometimes used to praise or demean the quality of an inductive argument. The idea is that you say, this is an example of strong induction when you would decide to believe the conclusion if presented with the premises. Alternatively, you say that is weak induction when your particular worldview does not allow you to see that the conclusions are likely given the premises. Strong induction. The gravitational force between two objects equals the gravitational constant times the product of the masses divided by the distance between them squared, has allowed us to describe the rate of fall of objects we have observed. Therefore, the gravitational force between two objects equals the gravitational constant times the product of the masses divided by the distance between them squared. The conclusion of this argument is not absolutely certain even given the premise. At speeds we normally experience Newtonian mechanics holds quite well, but at speeds approaching that of light, the Newtonian system is not accurate and the conclusion is that case would be false. However, since in most cases that we experience the premise as stated would usually lead to the conclusion given, we are logical in calling this argument an instance of strong induction. Even very strong inductions are potentially flawed interpretations of the truth, however reasonable and logical they might appear. Weak induction. Consider this example. I always hang pictures on nails. Therefore, all pictures hang from nails. Here, the link between the premise and the conclusion is very weak. Not only is it possible for the conclusion to be false given the premise, it is even fairly likely that the conclusion is false. Not all pictures are hung from nails. Moreover, not all pictures are hung. Thus, we say that this argument is an instance of weak induction. The previous is an example of probabilistic reasoning which employs weak induction. Therefore, the previous example is closer to an example of probabilistic reasoning rather than induction. Weak induction is merely a type of conjecture, not a proof. The problem of induction. Induction helps us to derive general conclusions on the basis of some known facts, and the conclusions thus derived are applicable to all known as well as unknown instances of the given case. This jump from a known instance to all instances is technically known as inductive leap. Inductive leap is a necessary step in all inductive inferences. The main problem of induction is to explain how we reach universal conclusions having material validity. Before arriving at universal propositions, one cannot examine all the particular instances of the given phenomenon. In many cases, it is something impossible. So, to reach universal propositions through induction, we do not study all particular cases. Instead, we observe a sufficient number of individual cases and try to analyze them in detail. After this, we presume that all other unobserved instances of the case will also agree with the cases already stated. Postulates of induction. The problem of induction can be solved by asserting certain postulates. The term postulate refers to simple self-evident universal truths. It is something above and beyond proof. They are also known as axioms. A postulate is assumed or supposed to be true. Scientific knowledge is necessarily based on certain postulates. The postulates are: number 1, the law of universal causation; number 2, the law of uniformity of nature; number 3, the law of unity of nature. The law of universal causation. The law of universal causation expresses the view that everything that exists and happens on this earth must have a cause. There is no causeless event in this world. Something cannot originate out of nothing. Every effect is preceded by a cause. Causal relation is applicable to the whole world and it is universal. According to Mill, cause is the totality of conditions of which the effect invariably and unconditionally follows. The law of uniformity of nature. Nature is working on the basis of certain fundamental laws. As there is regularity and uniformity in nature, what is once true is always true. If the conditions are similar, the same cause will certainly give rise to the same effect. For example, ice cubes melt whenever they are exposed in room temperature. This is due to the fact that things existing in identical conditions obey certain invariable laws. The law of uniformity of nature does not rule out variety in nature, but implies unity in diversity. Crichton says, things of the same nature produce under the same conditions the same kinds of effect. The law of unity of nature. Things having entirely different characteristics are interrelated in some way or other. This world is a cosmos in which different things are connected together to form a systematic whole. Nothing can exist without depending of others. Harmony is the very essence of nature. Without accepting these three postulates, one cannot arrive at any generalization. Without generalization, induction is impossible. These postulates are not essentially different from one another. The universe is an organized whole or system in which all things are interconnected and interdependent. Kinds of induction. Induction has been divided into two: improper induction and proper induction. Scientific induction alone is proper induction. Perfect induction, clarity of reasoning and colligation of facts come under improper induction. A. Enumerative induction. Induction is based on enumeration or simple counting of instances is called enumerative induction. There are two types of enumeration. Number 1, induction by complete enumeration or complete counting or perfect induction, and second, induction by simple enumeration or imperfect induction or incomplete counting. Perfect induction. This is a process of induction in which we come to a generalization after counting all particular instances. It is also done by counting each and every particular instance coming under the same class. Perfect induction is a kind of improper induction. For example, after counting and collecting data about all the students in a particular class, we can conclude all of them are graduates in philosophy. Perfect induction is not at all genuine induction. The conclusion reached by this method is universal only in appearance. It is only a collective universal obtained by adding all the instances together. There is no addition of new knowledge. It is simply a shorthand record of known facts. In perfect induction, there is no effort to analyze and explain the causal relation of the given phenomena. Perfect induction is possible only if the number of particular cases coming under the universal proposition is limited. When the universal proposition stands for an indefinite number of cases, this method is not applicable. So, it is limited in scope and does not have the characteristics of true scientific induction. Merits of perfect induction. It saves our time and effort because it sums up a number of individual propositions into one proposition. It avoids repetition. It is helpful in the process of analysis. The universal propositions derived through perfect induction are beyond doubt. Imperfect induction or simple enumeration. Imperfect induction or induction by simple enumeration is adopted when it is not possible to count all the instances. In such cases, we count some of the instances and make a general statement about all the instances including the unobserved cases. So, simple enumeration points to the truth that what is right of several objects of the same kind or class is true or right universally of that kind or class. The method is called simple enumeration because it is a process of simply counting the instances that share a common quality. For example, all crows are black. In this proposition, we cannot claim necessity of truth. In imperfect induction, we apply inductive leap, but it is not regarded as a scientific method. It can give only probable conclusions. A single contrary instance is enough to disprove the universal propositions derived through this method. B. Scientific induction. Science describes the facts of this world by revealing the underlying causal connections in accordance with general proposition or general laws. Mill and Bacon expressed the view that scientific laws are formed with the help of inductive inference known as scientific induction. They believed that general propositions or laws in science could be derived with the help of scientific induction. Scientific induction is the method of arriving at generalizations from the study of particular facts. Scientific induction explains us that causal relation invariably and necessarily exists between facts. Scientific induction aims at establishing universal laws true for all times and places. To attain this, observation and analysis of particular facts is necessary. In order to establish general laws in scientific induction, one must first of all accept the principles of uniformity of nature and universal causation. So, in scientific induction, the primary steps are observation and selection of the necessary number of instances, and the next step is the analysis of facts. Then only we can find out the causal connection between the facts. So, analysis of facts is none of the important requirements of scientific induction. From the analyzed facts, we immediately derive a universal law applicable to all observed as well as unobserved cases. So, inductive leap is another important feature of scientific induction. Scientific induction helps us to establish a real universal proposition having both formal and material validity. Observation and experiment are the material grounds of induction, and the formal ground of induction are the postulates. There are 4 stages in the method of scientific induction. They are: number 1, observation of facts, 2, formation of hypothesis, 3, verification of hypothesis, 4, proving the hypothesis. Observation of facts. In scientific induction, we begin with observation and description of facts. Observation is perceptuation with a definite purpose. Proper or suitable cases or facts from different sources are collected and analyzed in order to determine their nature or to discover the causal relationship inherent in them. In this process, each and every factor that is present in the complex phenomena is analyzed. While accepting the essential factors of the phenomena, unnecessary materials are eliminated or excluded. So, inductive method is preceded by analysis as well as elimination. At the first stage, we systematically and carefully observe a few cases and find out their common characteristic. We generalize about the whole class on the basis of some observed cases. Formation of hypothesis. After observation of facts, there is a tendency in us to describe the observed facts. We will guess about the cause for the observed fact. The initial guesswork, which is presented as an explanation of the observed facts, is known as hypothesis. A hypothesis is the assumption about the cause of a phenomenon, or it is a temporary or tentative explanation about an event or phenomenon. It is an assumption to guide further analysis. An observer must have some creative insight, and then only he can frame a useful hypothesis. There may be more than one hypothesis at a time to explain a particular phenomenon, but all of them cannot be true. Verification of hypothesis. The hypothesis formed in the course of analysis must be verified by relating them to actual facts. Then only we can conclude which of the hypothesis is true. This is the process of verification. It helps us to select the correct hypothesis. There is direct as well as indirect verification. With the help of observation and experiment, the hypothesis can be at once verified with reference to the actual event. This is known as direct verification. In indirect verification, we at first assume the hypothesis to be true and draw or deduce certain conclusions from it. Then, the deduced consequences or conclusions must be compared with actual events or facts. If the deduced conclusions or consequences are in agreement with actual facts, the hypothesis is said to be true and is verified. If the deduced consequences are not in agreement with actual facts, then the hypothesis is either eliminated or altered. Verification is not the final stage in scientific induction. After verification, it is possible to say that the hypothesis explains the fact. But the aim of induction is to demonstrate that the given hypothesis is the one and only one explanation for the given phenomenon. Verification gives us only incomplete explanation. So, in order to establish a hypothesis, we have to go beyond to prove the verified hypothesis. Proving the hypothesis. At this final stage, the verified hypothesis is tested to show that it is only adequate explanation of the given phenomenon. The same fact or phenomenon may be explained by different theories or hypotheses, but only one can be the apt one. To decide which hypothesis is the apt or the correct one can make use of the crucial instance. A crucial instance will help us to select the right hypothesis and to avoid wrong ones. So, in scientific induction, crucial instances have an important role to play. It will help us not only to prove the hypothesis, but also to select the right hypothesis. Hence, we can say that crucial instances help us to find out and test hypothesis. If the crucial instance is provided by experiment, then it is called a crucial experiment. For example, Queen Sheba wanted to test the wisdom of King Solomon. For this, she placed at a distance two flowers, one natural and the other artificial. Both looked alike. Sheba asked Solomon to point out which was the real flower. The king asked to keep all the windows and doors of the hall open. After some time, the bees attracted by the natural flower came in and settled on the real flower. In this example, the arrival of bees is a crucial instance because it helped the king to distinguish the real flower from the other one. The proven hypothesis is called a law. In order to arrive at the universal law, induction needs the help of deduction. The universal law is at first accepted as a hypothesis. The next step is verification of hypothesis, for which we mentally deduce the consequences from the conclusion. If the actual facts agree with the consequences of hypothesis, we can accept the hypothesis as true. Thus, for the verification of the hypothesis, we have to use deduction. We can conclude that both induction and deduction are necessary for scientific knowledge. They are thus complementary modes of reasoning. Now, let us summarize. This section deals with inference and its two types, namely induction and deduction. In induction, material truth is important, but in deductive logic, only formal validity is considered. They are two aspects of one and the same process of reasoning. This section analyzes the types of induction and its characteristics. Perfect and scientific induction are included in this. Scientific induction is dependent upon four stages, namely observation of facts, formation of hypothesis, verification and proof. The verified hypothesis is called a theory. The theory should be proved and the proved theory is known as law. There are some assignments for you to work out. Number 1, explain induction and distinguish it from deduction. Number 2, define scientific induction and describe its various stages. Number 3, postulates are the basis of induction, elucidate. Number 4, deduction is formal logic, explain. Number 5, induction gives importance to both formal and material validity, explain. There are a few books for your reference. Number 1, Cohen R. Morris and Ernest Nagel, An Introduction to Logic and Scientific Method, Allied Publishers, New Delhi, 1976. Number 2, Copy M. Irwin, Introduction to Logic, Macmillan, New York, 1982. Number 3, Sullivan J. Daniel, Fundamentals of Logic, McGraw-Hill Book Company, London, 1963. Number 5, A Textbook of Logic, SCRT, Thiruvananthapuram, 2003. I hope that you have enjoyed this session and we can meet later with another topic. Till then, bye. Thank you.